Okay, so now we're going to go into division of radical expressions. So if you look here, I have a square root of 96 divided by square root of 3. Okay, great. They're both monomials, one term. They're both radicals, which means the 96 and the 3 are the radicands. So the rule is you don't have to simplify first and break these terms down. What you need to do is do the division. So if we divide 96 by 3, that will divide evenly. So forget the root symbols are there and just divide 96 by 3 and you would get 32. But because these are both inside the radical sign, that means your quotient is still inside the radical sign. So the square root of 96 divided by the square root of 3 is the square root of 32. And the reason why is, remember, if this is broken into 2 square roots, technically we could rewrite it as 1 square root as a fraction. And if we rewrote this as 1 square root with a fraction, we would do 96 divided by 3 and get 32. So instead of writing this step down, we're just doing it in our head. Now, the problem is, can we leave the square root of 32? Square root is an operation. We're going to look to our square root list. 32 is not on my list, but I do know a perfect square in 32. So if I look at my list, 4 times 8 is 32, so 4 is a perfect square in 32, but is that the biggest? No. The biggest perfect square in 32 is 16. So that's what we have to use. Just like when we reduce fractions. When you reduce fractions, you always use the largest number in common, the GCF. That's what we're doing here. We're using the largest factor in common. It just so happens it has to be a perfect square. So we're going to rewrite this as the square root of 16 times 2. We all know the square root of 16 is 4, so we did that operation so the 4 comes out. Can we square root 2? Well, no. 2 is not a perfect square. It's not on the list. And 2 is prime. It's in lowest terms, so he has to stay inside. So the square root of 96 divided by the square root of 3 is 4 times the square root of 2. Okay? Now this works for any root. Let's do a cube root. I have 25 cube root of 250 divided by negative 5 cube root 2. So now we have coefficients. Again, this 25 and this negative 5 are connected to the roots by multiplication. As long as all our terms are monomials connected by multiplication, you can do division. So we know 25 divided by negative 5 would be negative 5. That was easy. And we know that negative 5 is in the numerator because that's what the bigger value is. Now we're going to divide. Our index are both 3, so we can divide. They're both cube roots. So what is 250 divided by 2? That would be 125. So the cube root of 250 divided by the cube root of 2 is the cube root of 125. And that also would have been in the numerator because that's what the bigger value is. So now the question is, can I leave negative 5 cube root 125? Well, we're doing a cube root, so we'll go to our cube root list and we'll see, hey, 125 is a perfect cube. So we should know that value. What number times itself 3 times would give you 125? Very good. So the cube root of 125 is 5, and that 5 would be connected to this negative 5 by multiplication because we're side by side. And negative 5 times 5 means our answer here is negative 25. Okay, I'll see you to do more division in the next module.